Hi everyone, I'm Parth Panchal, a GSOC contributor at OpenMRS. I'm currently working on building an offline capable Android application for LMICs that is integrated with the enhanced OpenMRS 3.0. I'm very lucky to be working under the mentorship of Frederick Deniger and Jose Francisco. This is going to be an offline first FHIR compliant Android application which is integrated with the OpenMRS server, where the user primarily is able to modify patient records and complete forms when they're offline. And once they have the access to an internet connection, they can synchronize all of these changes back to the server. Now let's dive into the technology used in the server. So we have Android, FHIR, FHIRPath, Google Android FHIR engine, and the SDC, the OpenMRS backend, and Docker for running our backend application. So out of this, like FHIR is a fast healthcare interoperable resource, which is a data specification primarily used to transfer medical records from like one system to another. Then we have FHIRPath, which is a simple path-based query to access the FHIR resources in our questionnaire. Then we are using the engine library from Android FHIR, which helps us to store the FHIR resources locally, query it, keep track of which one's offline, which one's on server, gives us the ability to sync. And then we have the structured data capture, which allows us to fill the questionnaire and extract the FHIR resources from the saved questionnaire response. Now let's dive into the main features of the application, starting with the synchronization. So this feature allows the user to upload and download resources to the server. We primarily use the sync API by the engine library, but one of the blockers that we had was that the engine library only supported a whole bundle transaction to save the resource. And the way OpenMRS works is that it requires individual resource save request for each FHIR resource. So we communicated with the Google team and they provided this support to the application. Next, we sync data with the use of a timestamp. This is done to make sure that no duplicate data is being downloaded and appropriate data is being synced. And then we make sure to like integrate it only the relevant resources in the synchronization function. So basically, like there are many different type of FHIR data, but only the ones which are required by the application are being saved. Next, we have integrated the main feature of our application, that is the patient registration. So here the user is able to register a patient offline and then is able to sync it back to the server. We have also integrated like location and identifier for the patient and an indicator to make sure that this patient is just saved offline and is yet to be synced back to the server. So next we have locations and identifiers. So in this, the key point is that with location, the user is only able to select the location he or she has access to, and once they have selected a location, then this information is embedded in the patient's register. Also similarly with the identifier, the user is able to see which of the identifier are supported by the server and then select one from it. And once the user selects an identifier, since this is going to be an offline application and we want to make sure that the identifiers aren't duplicated, we fetch 100 unique identifiers from the server itself. So whenever user saves the patient, the fetched unique identifier is being added to the patient. Since this will also be a white label application for other implementers, the following resources can be helpful. The first being the official repository of the application and the Dockerized setup of the OpenMRS backend. Then the Google's Open hashtag Android SDK, particularly engine and data capture, and also the OpenMRS wiki of the project where there is information on how the implementation is done. Now let's dive into the application. So starting with the login screen. So once a user opens the application, it shows the login button, and when a user presses on it, it opens the Keycloak login interface, and the user is allowed to enter their credentials, and then once it is successful, the user is redirected to the application again. Once a user is logged into the application, you can see that on the side pane it is shown that the no location is selected and it hasn't been synced yet. And also when a user tries to register a new patient, it is not allowed to do so because for each patient it is important to have a location selected. Now let's look into the select location flow. So first a user selects the location, and here we see the location screen. So all of these locations are the ones that are assigned to the user, and if the user if the list is too long, they can search for the particular location. And what happens is that if a user clicks on the star, then that location is being saved as a favorite. So the next time, if the list is too long, they can quickly find it on the top of the list. And only when a user taps on the location itself, it is highlighted and updated in the application. So this information is persisted across the app, and this location is also being embedded to the patient resource. After selecting the location, the user can select the identifier. So this is the patient identifier type. So here, as you can see, that this server has identity card, OpenMRS ID, HSU ID, legacy ID as the identifier type. So when a user selects the legacy ID and it is connected to the server, then the application fetches about 100 unique identifier for that identifier type. So here the application has fetched 100 unique identifiers for the legacy ID, and whenever a user registers a new patient offline, then that unique identifier is being attached to the patient resource. Before creating a patient, let's first look at our current patient screen. So as you can see, these are all the 58 patients that were stored on the server and are now accessible on the application. We have the option to search for a particular patient, and then here in the screen itself we can see all the patient details and the encounters that were filled. Now let's take a look at the main feature of the application, that is the patient registration. Here a user clicks on register patient, it is for the selected location floor. Then the user is entering the name, the family name, and all the relevant patient details. So as the user is like about to save the patient, so what happens is that once the user clicks the submit button, the SDC creates a questionnaire response, and that questionnaire response is used to extract the relevant FHIR resource. In this case, it would be a patient FHIR resource, and it has the location information and the identifier information embedded in the resource itself. And currently, this patient is only saved locally. So if we go back to the patient list, we can search for the patient name, and it will have an offline indicator like this. So it allows users to distinguish between what's saved and what resources are still just in the application. So now once a patient is like synced successfully, we can go back to the patient list and search for the patient again, and we can see that this time it no longer has the offline indicator. And if we go to the OpenMRS backend, selecting our location, we can search for the patient that was saved on the mobile application, and it is accessible on the server. So yeah, this has been the complete flow of application we have achieved so far. And next we are looking to add features for editing the patient, editing encounters, and bring some UI changes to the application. Before ending, I'd like to say my special thanks to Jayasankar, Piyumal, and Grace for helping me throughout the Google Summer of Code program, and Pedro and Lewis from the ICRC team for supporting me through the development. And also special thanks to everyone who's been involved in this wonderful OpenMRS community. Thank you for watching. I wish you all a great day.